In this video, we will learn how a speaker works by examining its parts, how they function together, and how they convert electrical signals into sound that we can hear. First, let's look at the components that make up the speaker. Inside the speaker, there are two major components. One is the circuit board, and the other is a combination of magnets and suspensions. Circuit boards contain components that convert the musical waveform into electrical pulses. This is the most important process in the speaker because if the converted waveform is inaccurate or contains any type of noise, it can completely ruin the sound quality and cause important details to be lost. Next is the magnet. All loudspeakers have a permanent magnet or an electromagnet with a circular gap, within which the voice coil and diaphragm move. It is the interaction of these parts that generates sound. This magnet is sandwiched between two metal plates. These metal plates act as flux concentrators, meaning they help to concentrate the magnetic field of the permanent magnet, which increases the speaker's efficiency. The coil positioned slightly above the center of the permanent magnet is called the voice coil. It is made by winding thin copper wire around a heat-resistant cylinder. This coil acts as an electromagnet when current passes through it, causing the cone to move up and down. The coil is placed just above the center of the magnet to avoid exposure to the strongest magnetic field and to reduce distortion. If it is placed too far from the magnet, the speaker will have a slight time lag between beats, which reduces its accuracy. For stable and smooth cone movement, suspensions made of elastic material are used. Suspensions are crucial for improving the quality of the sound produced. There are two suspensions in total, one around the upper circumference of the cone and one below the cone. A dust cap is used to prevent dust from entering the internal components. Now, let's see how all these components work together to produce soothing sounds from electrical pulses. After the sound waveform is converted into electrical pulses, these pulses are sent through the coil. When current flows through a conductor, it generates a magnetic field, the direction of which depends on the direction of the current. Similarly, a magnetic field is produced in the coil. When this field interacts with the magnetic field of the permanent magnet, it generates either an attractive or repulsive force between them. If the directions of the two magnetic fields are opposite, an attractive force is produced. If the directions are the same, a repulsive force occurs. When a repulsive force is produced, the coil, along with the cone, moves forward, away from the magnet. When the force is attractive, the coil is pulled closer to the magnet, moving the cone backward. As the cone moves back and forth, it causes vibrations in the surrounding air molecules. These vibrations create waves, more accurately pressure waves. When these pressure waves reach our ears, the eardrum responds to the movement of the air molecules, and our brain interprets these movements as sound. The cone moves faster to increase the pitch of the sound, and slower to decrease it. Similarly, for a loud sound, the amplitude of the cone is larger compared to a low sound. If you have any questions or feedback about the video, please feel free to comment below. I'd love to hear your thoughts so I can continue improving and help you learn something new.